So today, since I'm not here, I have a lesson for you on compound interest. So we went over simple interest earlier, like in the last class, and now we're going to hit on compound. So compound interest is something that you'd like a little more than your simple interest when it comes to making money. Simple interest you like more when you have to, or when you are owing somebody money. So the difference between the two. I'm available during class, so I'm going to find a way for you to be able to ask me questions and I can ask them live. I'll have my phone with me so I can look stuff up. The directions for how to do that will be in the classroom, and I will try to answer them as efficiently as I can. But the difference between compound interest and simple interest is that compound interest gets added on per year or per month, depending upon what is in your bank account. So for example, like if I start with $100 in my bank account and 10% compounded annually. So that means I'm going to make 10% on it every year. But what's going to happen instead of doing the 10% of 100 every year, it's going to get me 10% of whatever is in my bank account. So year one, I'll make $10, so I'll have 110. Year two, then I'll make 10% of this number, so I'll make $11. So I'll have 121. Okay, so when interest is compounded annually, it's not off of the initial amount, it's off of what is there each time. Simple interest just takes the percent from the beginning and rides it out the whole time. So our simple interest formula we had was the I part. Interest equals principal times rate times time in years. But because with compound interest, the interest in the account depends upon the amount at the beginning of the year, not at the beginning of time. We take away the t in I part and keep repeating the formula t times. So we'll use the interest equals principal times rate, but we'll have to restart our principal amount. So this principal will restart. So each year it'll be a new principal amount because you'll put in the amount that's there at the beginning of the year as your principal instead of the beginning of time. And I'll do some examples for you, so don't get too overwhelmed right now. But this can get super long, because what if I want to know how long it is for 25 years? We would have to do that formula 25 times. That's a lot of opportunity for error, and that's a lot of work that I don't want to do, and I don't think you want to do either. So there's a new formula that we can use for compound interest. Okay, so this is something to write down and have somewhere, and make sure you know the difference. Because like on the test, I'm going to give you I equals P RT, or on a test that's standardized, or whatever. They're going to give you the letters, so B equals P 1 plus RT, but they're not going to tell you what they mean. So right now I have in here the words, but when it comes down to it, you're not going to have those given to you, so you're going to have to know those in your brain. So this one, it gives us the balance equals the principal times 1 plus the rate to the power of the time in years. And once again, I'll give you an example so you don't have to freak out. But this balance one is the one that I would rely on because it's only one step that you have to take rather than 25 or however many you'll have to take with the other. But I will still show you how to do both so that you have that option. So we have this example here that says Brennan has $10 in a savings account. The interest rate is 10% compounded annually. To the nearest cent, how much will he have in 2 years? So over here, I'm going to do the I equals P R repeat t times. And over here, I'm going to do the b equals p 1 plus r to the t. So, things up here that are important. When I'm doing this, I like to just go in and point out the numbers, because the numbers are the things that matter. So we have $10 in a savings account, interest rate is 10%, and to the nearest cent, how much will he have in 2 years? So there are my 3 little pieces of information. Now I'm going to kind of label which one is which. So things I need to know the principal, I need to know the rate, and I need to know the time. So if he has $10 in his savings account, principal, rate, or time, our principal is the initial amount that we have. That's our $10. So he starts off with $10. The rate is 10%. I need to make sure I'm writing our interest rate as a decimal instead of putting 10. So when percents, you take off the percent sign and move the decimal 2 spaces, so we get 0.1. And the time is 2 years, so that's 2. So doing this first formula, the I equals PR repeated t times. I'm looking for the I don't know. That equals my principal of 10 times the rate of 0.1. And this 10 times 0.1 gives us an interest of 1. So his interest is $1 there. This is year 1. In order to be able to do year 2, I have to figure out what my principal for year 2 is. So new principal is the original principal plus our interest, which is going to be $11. So when I do this problem for year 2, I'm going to have I equals 11 times 0.1, which gets us an interest of $1.10. Which means the amount in the bank, so new balance, the new amount that he has, is our $11 plus the 110 to get us $12.10. Okay? We see how this can get a little hard to organize, a little messy. It's a lot of work, a lot of steps, a lot of opportunities for error. So what we can do is I'm going to make sure I get myself a calculator here. So I'm going to run to the back room. I'm sorry. Okay, I now have my calculator. I'm going to plug these into this new equation. So my balance is what I'm looking for. My principal is 10. 1 plus my rate is 0.1 to the power of t, which is 2. Now, something that I really want us to work on here as 7th graders is not just punching it all into the calculator and trusting that it's going to get it right, because your calculator will do you wrong. A lot of you learned that lesson the hard way when we were doing percent of change on the assessment. You wrote out your equation right, but you just punched it all into your calculator. It's not a very nice thing. So I'm going to kind of break this down. 10 times 1.1, because 1 plus 0.1 is 1.1, to the second power. Remembering our order of operations, I have to do the exponent first. So I'm going to make sure I'm not doing 10 times 1.1. I'm going to do 1.1 to the second power first. B equals 10 times 1.21. Now I'm going to do 10 times 1.21. and I get a balance of $12.10. This side, to me, in my opinion, is much, much, much easier than using the IPERT equation. So memorizing this and how to use it is something I highly, highly, highly recommend. You want to be careful and make sure it's not asking you for the amount of interest that it's asking you for the balance. So in this case, to the nearest cent, how much will he have in 2 years? The $12.10 is how much he'll have. If it wanted to know the amount of interest, we would have to take our original amount off of this new balance to learn the interest he got was $2.10. So just reading your question and making sure you know what it's asking for is very important. Okay, I want you to pause and attempt to solve this problem on your own. Check your work to see how you did and correct any mistakes. So I'm also going to solve this, but I want you to do it by yourself and check to see that I got the right answer. Or that you got the right answer. I, of course, am going to get the right answer. I'm going to solve it both ways for you to check with. Pick one. You don't have to do it both ways. Pick one that you want to stick with and do that. So pause here, solve it, and then check back with me. So here, my principal is $8. My rate is 5%, so that's 0.05. And my time is 1 year, which is nice because it's just one, right? So my interest equals 8 times 0.05. Handy dandy calculator, 8 times 0.05 gets me an interest of 40 cents. And that would mean my balance is $8.40. Let's check over here with our B equals P1 plus R to the T. My balance equals 8 times 1 plus 0.05 T, which is just 1. I don't even have to write 1, to be honest with you, but I'm going to do that for you in this case. So our balance equals 8 times 1.05. 1.05 to the first power is still just straight up 1.05. So 8 times 1.05 will get us a balance of 840. So my balance is 840. Cool. Got it solved, right? Pranked. The answer is 40 cents. Okay? I thought it was funny and then I did not play that off right. So sorry, that was not very funny. But it wants to know how much interest will he earn. So this equation gave that to us. I equals 40 cents. Over here it gave us our balance. So it gave us how much he had in the account. So you need to make sure that you are going back and going, okay, if he started with 8, now he has 840, and I just did that backwards. So he has 840 right now. He started with 8. That means he got an additional 40 cents. So really make sure you're differentiating between those problems, okay? Like I've been saying, you may choose whatever formula you wish to use. I show you both so that you can make the choice. Once again, I really would recommend using the balance formula instead of the interest, but it's up to you. You make your own choices. You're old enough to make your own choice, and some of you, that other one might be easier for you. It's not for me. I will have posted in Classroom the practices for you to do and kind of directions for the whole day. So do your best, work hard, remember to help each other. Since I'm not there, you're really going to have to rely on one another to figure stuff out. And I really know that you guys can do that. So, good luck.